So hello again, this is the second video about computing powers modulo n. So in the previous video, we've seen why we shouldn't try to calculate in the first place 19 to the power of 23, then apply modulo 29. So we can have the idea of applying modulo each time we make a multiplication. That would mean that we start from 19, then calculate 19 squared modulo 29, which would give us a value which is between 0 and 18. And actually, 19 squared modulo 29 is equal to 13. So let's go on from this value. We can now calculate 19 to the power of 3 modulo 29, which would be 13 times 19 modulo 29, which would give us 15. So we see that actually at each step of the calculation, applying modulo 29 will give us a number which is actually between 0 and 28 that would keep the calculation feasible for a computer or even a standard calculator. So let's go on for another steps. From 19 to the power of 3 modulo 29, we can calculate 19 to the power of 4 modulo 29, which should be 15 times 19 modulo 29. That would give us 24, and so on until we reach the value of 19 to the power of 23 modulo 29. So actually, instead of computing a very huge number and applying modulo 29 only after this calculation is done, here we can go through steps where we apply modulo 29 at each step. So actually, this would lead to 23 multiplications and applying modulo 29. So sounds nice, but actually, when using such calculations, especially with the RSA crypto system, the exponent would also be a very huge number. So actually, you have as many steps or as many multiplications and applying modulo than the value of the exponent. So sounds nice because it avoids calculating very huge numbers which are out of scope of calculators of computer, but it's still not efficient enough if the exponent is a big number. So we'll see how to handle it in the last video of the chapter, how to be even more efficient for this calculation.